Alright, so we're going to start with our GCF factoring. Does anybody know what GCF stands for? Greatest common factor. So the main idea for greatest common factor factoring is you're just looking to see what does everything have in common, and then you're going to divide it away. That's essentially what we're doing. So when you're looking for the GCF for the greatest common factor, it could be a number, a variable, or both of those things. You're just looking to see what numbers do they have in common, what variables do they have in common. Once you identify that, you're just going to divide it away and then write it out after that division. If the leading coefficient is negative, this is a very important bullet right here. If the leading coefficient is negative, that negative would be considered the GCF. When you guys are factoring, you're never allowed to have a negative at the very front of your expression. So if you see a negative at the front, that needs to be part of your GCF that you're going to divide away. So be on the lookout for that. So let's look at example number 1. What you need is two things out of common. What's something that you could divide away for both of them? A 3. Do they have any variables in common? No. So the GCF would be 3. Once you guys identify the GCF, you're going to write it down. 3. Okay? Then what you're going to do to factor is basically undoing multiplication. Factoring is another way of dividing, kind of. Stretch, but it's a form of division. So I want you guys to tell me, if I divide the 3 away, what would be left? X squared minus 5. This is the factored form of that polynomial. That's all you do. You figure out what can you divide from both of them, and then you do that. So, if I wanted to check the answer, what could I do? You could multiply or distribute. So this kind of factoring is actually the undoing of the distributive property. So if you want to check to see if you did it correctly, just distribute back through and you did that back through. Okay, so we're like undoing the distributive property. All right, what do these have in common? So they have an x in common. You could take an x out of both of those, right? Could you take an x squared out of both of them? No. So when you guys are looking at coefficients, when you guys are looking at the exponents, the smallest one that they both have is going to be the GCF. Okay? Now, do they have any numbers in common that I could remove or divide? And negative. Again, this is that special case I was talking about for the second bullet. Is there a negative in the front? That needs to be part of your GCF. They both have an x in common, and they both have a minus 1 as something you could divide away. So that's my GCF, negative x. Now, if I divide everything by negative x, if I undo the distributive property, what would be left behind? 9x plus 7. Because I took out that minus, then this becomes a plus. Just think of it as division. Okay? All right, what do these have in common? It's nice to break it up into pieces. So let's look at number 3. What number could you divide from each of those? 4. And then what variable, if any, do they have in common? X. Do they all have x squared? Do the first two have x squared? Yes, but in order for it to be a GCF, all of the terms need to have that. So the biggest thing that they all have is just x. Okay? So that's my GCF. So if I divide everything by 4x, what would be left behind? Nope. What? 1. When the GCF is one of your terms, when you divide something by itself, it leaves the 1 behind. One of the most common mistakes I see with factoring is that when you guys see that you're dividing something by itself, you call it a 0. Something divided by itself is 1. It doesn't poof, just disappear. It divides by itself, it leaves a 1 behind. Okay, so if I start with 1, 2, 3 terms, my answer should still have 1, 2, 3 terms inside of the term. You can't take something that has 3 terms and turn it into something that has 2. Questions on the first 3? Okay. What about number 4? What number do those have in common? Just negative 1? What's the biggest thing that they have in common? You can divide out an 8, right? But what I want positive 8, negative 8. You can divide 8 or negative 8 and 40 by 8, but you want to include the negative at the front. Anytime there's a negative at the front, that needs to be included in your GCF. All right? Do they have any variables in common? Nope. Okay, so negative 8 is the only GCF. So what would be left behind? Minus 5. This is positive, so if you're dividing by negative, it leaves negative sign. Okay. So basically, when you guys pull out the negative, it just changes all the time. Okay. Questions about that one? Okay. Next. Okay, so because of the negative at the front, that needs to be part of your GCF. So you immediately write that down. If you see negative at the front, write it down as part of your GCF. Do they have any other numbers in common besides the negative? Numbers. Do they have any numbers in common besides the negative? No. Do they have any variables in common? What's the biggest biggest variable that they both have in common? X squared. I know you guys are tempted to say, okay, well they both have an x, and that's true. But you guys, it's the greatest common factor, so you want to pull out the biggest thing that they both have in common. In this case, it would be an x squared. So if I divide by x squared, what would be left behind? Sorry, negative. X squared minus 3. Whenever you guys are dividing or variables with exponents, you subtract. So if I had x to the 4 and then I take 2 away, I have 2 left. Then our last one here. What is a number that all three of those terms could have divided away? 4. What's a variable that you could divide for all of them? X. Okay. So it'll be left behind. Okay, so this one used to be x to the 6, but because I'm taking an x away, it's now x to the 5, it goes down by 1. Plus, okay, minus 1. Again, this term doesn't just disappear. When you divide something by itself, it's 1. Left behind. Alright, does everybody see how we do greatest common factor? Break it up into parts. Think of number first, then variables, and then double check to see if there was a negative. Okay, make sense? Alright. Now we're going to do factor by grouping. This one's kind of fun. Factor by grouping, in every situation when you guys are factoring, always look for a GCF first. Because if you don't look for a GCF at the beginning and you start your process going down, it'll mess up the numbers at the end if you didn't take out the GCF at the beginning. So factor by grouping is exclusively for when you guys have 4 terms. Everybody knows what I mean when I say term, right? It's like parts of the polynomial. So look at all these examples. How many terms do these guys have? They have 4. So factor by grouping is used when you have 4 terms. You use different methods when there's 3 or 2. This is for when there's 4. So what you guys do, always look for GCF or a negative first. What you're going to do is you're going to start by splitting the expression in half. You're physically going to draw a line right through the middle of the expression. And so that changes our 4-term expression into 2 and 2, right? More manageable group. So when you split it in half, you're going to look at each pair, and you're going to find a GCF for each pair. And what happens that's really cool is that when you take out the GCF in both halves, what's left behind should be the same. And if that does happen, then you guys will be able to link everything. I'll show you guys in a second. You'll be able to link everything together to create your factor. Once you guys see it happen, it's actually really fun, and it makes a lot of sense. So the first thing we're going to do is look at number 1. Is there a GCF across the entire expression? Does every single one of these terms have something in common? No. So always check for that first. Now, because there's no GCF, you guys are going to take your pencil and you're going to draw a line right through the middle, right here, before the minus. After the y squared, before the minus. Right down the middle. Okay. Now, we split this into 2 and 2, so they're more manageable. So let's just look at the left side. What's the GCF of these 2 things? X squared. So the first 2 objects, you can divide x squared away from them. So that's the GCF of the first half. Write that down using space. If that's the GCF and I divide that away, what would be left? X squared plus y squared. Remember how did you do it? We're like undoing the distributive property, remember? Alright, then let's go to the right hand side. What's the GCF for those 2? Right, when we drew that line, it's very important you draw that so that it's in front of the minus, because now this minus is at the front of this expression. So part of the GCF has to be the minus, but is there anything else they have in common? 5. The second term over here doesn't have an x squared, so that's not part of the GCF. So for the second half, they both have negative 5 in common, so if I divide that away, what will be left? Nope. Because I'm taking out the minus, everything changes sign. X squared plus y squared. So this is that step I was telling you. You guys can actually do a self-check halfway through the process to make sure you did it correctly. If you take out the GCF for the left side, and then you take out the GCF from the right side, if you did it correctly, the things inside of the parentheses should match. Do you see how they're the same? That's how you know you did it correctly. If they don't match, you did it incorrectly, you need to go back and try again. Right? Once you're here, we only have one step left. To finish, all you guys need to do is pull these two together, the GCFs that you had on the outside. You're going to pull those together into their own factor. So they get linked together inside of parentheses. You have the x squared, and then because this is a negative 5, it's minus. And then the second factor is just whatever was in parentheses. And you're done. That is factor by grouping. Very simple. So you're halfway checked because if once you see on the GCF on the left and the right, you know you're right as these two things in front of you. Yep. Questions? Yeah. No, you want to leave them where they are. Leave them where they are. Yes? No. But that's an interesting question, and I'll address that in a second. It'll look like there isn't one. Okay, so for this next one, where would I draw that line to cut it in half? After the w squared before the plus. Okay, so I'm going to draw that halfway. Then again, I'm going to look on the left side and the right side, and I'm going to find the GCF. So what's the GCF for everything on the left side of the line? W squared. I can take a w squared out of both of those, so that's my GCF. And then what would be left behind if I divide? Minus 1. Again, if there are two terms, it should always be two terms. You can't turn something that has two terms into something that has one. Okay, if you're dividing something by itself, it's a 1. All right, now coming back to John's question, if I look, excuse me, if I look at these two, what would the GCF be? It's a 1. So they don't have anything in common per se to divide away. You guys need to have a GCF in order to do this process. So if they don't look like they have a GCF, call it a 1. You could divide a 1 for both of them. It's kind of insubstantial, but you can still do that. So if the 1 is a GCF, nothing changes. You're just going to write it as 3w minus 1. Okay, so again, with this one, with the GCF being 1, I noticed that what's in parentheses here and what's in parentheses here are the same. Did we do it correctly? Yes. That's your midway checkpoint. And how do I wrap it up? Because this was positive, you can call it plus 1. And then, voila. Not too bad. Alright, I forgot to ask the first question for this one. There is no GCF at the beginning of this one. Well, I always forget that. And it's important that you guys remember. At the start of every question, always ask if there's a GCF across the entire experiment. So there wasn't a GCF for the first two questions. So looking at number 3, is there a GCF across the entire expression? Is there something you could divide away from everything? Yes. So it's 2, and then if you divide that away, you get x cubed plus x squared plus 4x plus 4. It's very important to start the question by pulling out a GCF if there's one at the beginning. Because now what we're going to do is we're going to do the factor by grouping for what's inside of the parentheses here. Okay, so rewrite it with the 2 taken out as a GCF, and then we're going to factor this expression that's here, that I've written in blue. Okay, so split it down the middle, or pull out the GCF. The 2 is going to be part of our final answer, but I'm going to let it float along until we get to the end. I'm not going to keep writing it until the very, very end. So let's stick it here. All right, what is the GCF of this first half here? What does x cubed and x squared have in common? An x squared. You can take an x squared out of both of those, so that's considered a GCF. If I divide by x squared, what would be left behind? X plus 1. So if you take an x squared away from x cubed, you only have 1x left, and then x squared divided by itself is 1. All right, on this side, what's the GCF? What do 4x and 4 have in common? 4. So I'm going to divide 4 away. I'm going to undo the distributive property. What does that give me? X plus 1. So if you divide by 4, you get x plus 1. So how do I know I did it correctly? What's inside of the parentheses is the same. So now all you guys need to do is with your 2, or make sure you have the 2 in your final answer, just write that down. You're going to take the outside pieces, stick them together, and then inside the parentheses, write it down once, and then you have your factors. Okay? Make sense? So again, make sure you're looking for that GCF at the very beginning. If there is one, make sure you take it out before you get started, and then write that down immediately, so that that's part of your final answer when you write it down. Okay? I'm going to let you guys try the last 3 on your own. I'm going to give you a few minutes to do that, and then we'll go on to the next page. Yes, look for GCF to start. Alright, so let's take a look at this last one. So you guys probably want to remember to draw the line after the second term, but before the operation of the third one. So that side goes with that term. The GCF on this side, the biggest thing you can take away is x squared. I understand you can divide by x. That's true. But GCF, the G stands for greatest. You want to make sure you take the biggest thing away, which is x squared. If you have x times 3 left behind, the GCF, because there's a negative at the front, that's part of the GCF. We have 16. So you would get this. Did everybody get this answer? Okay. This one, put a star next to it. You've done the factor by grouping correctly, but this is actually not done being factored. We're going to talk next class about this right here, the x squared minus 16. That can actually be factored for. So if you saw a question like this where you did factor by grouping and you got here, this would not be your final answer. After you learn what we're going to talk about next lesson, you would have to factor the x squared minus 16 to actually get to your final answer. For now, we'll just leave it, because we haven't learned how to factor that yet. But in the future, once we've learned all of the different types, you would have to double check to see if you can be factoring at the end. This one, you guys should draw the line right there. What's the GCF on the left? What's the biggest thing that you can divide with both of them? 2x squared, which leaves behind x plus 1. This one's GCF is just 1. You get 2x squared plus 1, x plus 1. Everybody get that? Okay. And then over here, should I just jump right in? Is there a GCF across the entire thing? Yes. All of these terms have a C. So you can either catch that before or after. It's probably easier to catch it at the beginning rather than at the end. I'll show you what you can do if you didn't catch it at the beginning and you actually have it at the end instead. So if you pull out the C first, then it would look like this. So C being the GCF on the outside, and this is what you guys would use for factor by grouping. You have B cubed over here, C minus 1, and then 5, C minus 1. Your final answer should be, with your GCF of C, this is what your final answer should look like. Okay? If you guys did not catch the GCF at the beginning, you guys might have written this. If you didn't catch that there was a GCF at the beginning, you might have this answer. But this is not correct, because this is not fully factored. If there's something inside of the factors that you can divide away using GCF, then you have to do that before you get your final answer. So either catch the GCF at the beginning, take it out immediately, and then do all of your work, no problem. Or if you miss that, you guys will always, as a habit, have to check your final answer to see if there's anything you can divide away from either of the factors. So if you missed the GCF at the beginning and you got here, you should say, oh, I noticed they both have a C, so then you have to pull that out and then you can get the correct final answer. So either catch the GCF at the beginning or catch it at the end. So pick one. Get in the habit of checking for GCF at the beginning or checking at the end. I recommend checking at the beginning because that just makes it consistent across all of our types of factoring, like what we're going to see on the next page. So get in the habit of checking for GCF at the beginning. Always double check at the end, but try to check at the beginning. Any questions about factor by grouping? Remember, how many terms does your expression need to have to use factor by grouping? 4. Okay. So, this one on the next page, trinomial factoring, is the most important form of factoring. This is the one you guys will see the most. This is the type of factoring we're going to use the most for solving. It's the kind of stuff that's really going to stick with us for the rest of the year. This is like our foundation moving forward. You're going to keep seeing this over and over and over again. So you guys need to know, if you don't know any other type of factoring, this is the one you need to know. Okay? You need to know all of them, but this is the most important one. All right, so this is trinomial factoring. How many terms will each of these have? 3. So when you guys see a 3-term expression or polynomial, again, always check for GCF at the beginning. It'll make your life a lot easier if you check for it at the beginning. It actually could make your answer completely incorrect if you don't do it at the beginning, and then you can't catch it at the end. So make sure you're checking for it at the beginning. What we're going to do, and this is where it could differ, like if you guys learned factoring before, your teacher may have shown you a slightly different way of doing it, but I'm going to use one method consistently across all of these, just so we're staying with one method so you don't get confused. So what you're going to do, I like to draw this little arc like this. You're going to multiply the very first number in front of the x squared with the very last number at the end without a variable. So the first and last numbers, which we call a and c, we're going to multiply those together. I like to draw this little x thing. This helps me keep my work organized. You guys can use some other method, but I like to use this x. When I multiply those two numbers together, so for this first example, what's in front of the x? 1. And what's the last number? What's 1 times 12? I write that number here at the top. You're going to multiply the first and last numbers together, and then you're going to write down the middle number. This is a little bit of a brain activity, a little brain teaser. I need you guys to find 2 numbers that multiply to get this number, but add to get that number. Multiply these 12, add to get 8. 6 and 2. Those numbers go here and here. Okay, that's our setup. That's not the factoring process, it's just our setup. Once you guys find these 2 numbers, what you're going to do is you're going to rewrite our expression here. So instead of writing 8x, I'm going to use these 2 numbers to split this into 2 terms. So I'm going to write this as x squared plus 6x plus 2x. I'm going to take the 8x, the middle term that I was just working with, I'm going to split it into 2 parts, the 6 and the 2. Does everybody understand how this that I just wrote is exactly the same as the first one? It's just not simplified. Does everybody see that? They're exactly the same. I just rewrote the 8x as the addition of 2 different numbers. So they're exactly the same. Okay? Now how many terms do I have? What do I do when I have 4 terms? Factor by grouping, which is what we just did. Okay? So now I'm going to draw, this is a continuation of what we were just doing. It really builds on top of itself. So I'm going to draw a line down the middle. What's the GCF on the left side? They both have an x in common. So I pull out the x, I have x plus 6 left behind. What's the GCF on the right-hand side? What can you divide from 2x and 12? 2. And that gives me my x plus 6, so I know I did it correctly. And then you're going to pull the x and 2 together, and then write the x plus 6. And that is your factor 20. There you go. You take something that was originally 3 terms, you turn it into something that has 4, so we can use the type of factoring that we were just talking about. Alright, let's try another one. Alright, what do we do first? You don't have this one? Let's just change the order. Okay, what's the next one on your page? What number on here? This one right here? Okay, I'll just go in order. Alright, so what would I do first? Look for a GCF. Is there correct answer? Is there a GCF across those? No. So then what do I do? Multiply the first and the last numbers. What I got? And then what's the middle number? Okay. So I need to think of 2 numbers that multiply to get positive 6 but add to get negative 5. If you're not used to thinking of factors really quickly, you guys can just write them all down in the margin, like, okay, what multiplies to get positive 6? Write down a bunch of different combinations until you find the one that adds to get negative 5. If you're not like that, kind of light bulb, not then there's no q. And I'll just write this down. Find them out that way. And once I have it spelled out, what do I do next? To rewrite. Instead of writing negative 5x, I'm going to take that and split it into the two numbers I just found. Without changing anything else, it's just the middle number split. It does not matter what order you put them in, you will get the same answer regardless. Okay, once you've done that, I'm going to split down the middle. Make sure you're very careful to put that line before the minus, just in front of the street. Alright, what's the GCF on the left? 2x. They both have a 2 and x you can divide away. So it gives me 3x minus 1. 3x minus 1. And then what's the GCF on the right-hand side? Not just 1, it's a negative 1. Remember, anytime you have something you're looking for a GCF, if there's a negative at the front, that has to be part of your GCF. So without anything else they have in common, that negative is the GCF itself. I'm going to call it negative 1. Instead of just a negative, I'm going to call it negative 1. And then that leaves a 3x minus 1 behind. Because remember, when you pull out the negative, it's a GCF, it changes all the signs that were inside. Alright, so what would my final result be? That's why it's important over here with the GCF being negative, I physically write negative 1 so that I know what number is right here. You don't want to just write 2x minus. Right? If you just write a negative, maybe you don't know what's right. So I always write it as negative 1 when you're working that way. Alright, which one would be next for you guys? Number 3, okay. Alright, now these ones are highlighted because they're interesting. What's different about these ones that I haven't highlighted? They have multiple variables, x and y's. So this looks complicated, but it's actually not. What we're going to do is we're just going to pretend the y's aren't there for now. We'll bring them back at the end in a very easy, simple way. But when you guys see this, when you guys see x squared, and then xy, and then y squared. So it's kind of fading out of the x's and then fading into the y's. You see that? It decreases the x's and then starts increasing the y's. When you see that, the x squared and then the xy, y squared, all you guys are going to do is rewrite it without the y's. What would this look like if I took the y's out? Awesome. So put a little star and write y here to remind yourself that you took it out, but then just rewrite it without the y's. We're going to put the y's back at the end. Y at end, just to remind ourselves that we need to put it back. It's very simple how you put it back. But once I take them away, I'm just going to factor it as it looks right here. So just use the regular method that we have been doing already for the past two. Do the exact same thing for this. Okay? So then if I just saw this, how would I factor that? You look for a GCF, which there isn't. Okay? Then what? I'll multiply the first and last numbers, which gives me negative 15. And then what's the middle number? So I need two numbers that multiply to get negative 15, add to get negative 2. Yes. Negative 5, positive 3. You need to be careful with the signs, right? If you accidentally say negative 3, positive 5, those would actually give you a positive 2, which is not what I want. So you guys have to be really, really careful that the signs are correct to get you the numbers that you need, okay? Now what do I do with the negative 5 and 3? Say again? Okay, so we're going to split the middle number, so it's negative 5x plus 3x instead of negative 2x. We're unsimplifying, basically. Uncombining like here. So once I'm here, what do I do? Split down the middle, so I have 4 terms now. The GCF on the left, x, so I have x minus 5 left behind if I divide by x. And then what do the terms on the right have in common? 3. So I get my x minus 5. How do I confirm that I've done this correct? The insides of the parentheses are the same. By the way, don't force them to be the same. Don't say this is x, don't write the x minus 5 first and then try to figure out from there, because that kind of erases the self-check process. So just do it naturally, and if they don't match, go back and try again. All right, how do I write the final factors? plus 3 because the 3 is positive, and then x minus 5. Alright, this is what your final answer would look like if the question was originally like this. Once you finish the factoring, you do need to remember to put the y back at the end. It's very simple. All you guys need to do is put one y each into each of the factors, and they're going to go in front of the numbers that you have. So if you have the x already, and then you have the 3, you're going to put a y with the 3, and then you're going to put a y with the 5. And then you got it. So when you guys have the y's at the beginning, take them out, factor like normal, and at the very, very end, put one y, attach them to the numbers at the end of each of your factors. Yeah, so it is y squared. When you FOIL, this kind of factoring right here, I meant to mention this at the beginning, this type of factoring is the reverse of FOIL. On the previous page with GCF, that's undoing the distributive property. This is undoing FOILing. So if you guys want to check to see if you factored correctly, all you have to do is FOIL. So if you FOIL, that's how you get the y squared. Okay? So see how there are two, remember how I keep saying you're not allowed to distribute squares, you FOIL instead? So FOIL is when you have two binomials being multiplied, you do first, outer, inner, last. If you were to do that for these, you'd end up factory starting. Okay, so use FOIL to check if you guys are ever unsure about your answer. All right, which one of these would be next? This one? Oh, 4 is next. Okay, so 4 is 4. Awesome. All right, what did you for this one? First step. First step is look for a greatest common factor. Is there one? No. Next step. Multiply the first and last numbers. Maybe 30. Write down the middle number. Okay, so I need two numbers that multiply to get negative 30, but add to get 13. (15 and negative 2). 15 and negative 2. Now you guys were tempted with the 10 and 3, but you can't really get that to work with the negatives, to work with the negative 13 positive, sorry, the negative 30, positive 13. So if you can't get the signs to work, think of a different number combination. The 15 and the negative 2. So then I would take my expression, and instead of writing 3 terms, I'm going to take that middle one and split it into 2 using the 2 numbers I just found. That was the whole point of finding those 2 numbers, to rewrite the middle term. Then I split down the middle. What's the GCF on the left side? 3x. And then what's up behind? And then what's the GCF on the right side? Negative 2. Notice how that minus starts off our expression. If you have a minus at the front, that is part of your GCF. So I have minus 2. When I divide that away, that gives me my x plus 5. Remember, when you take out the negative, everything changes sign. So I know I've done it correctly because I have x plus 5 in both of these parentheses. So then how would I write my final answer? I also get a question, very common question, does it matter which one of the parentheses you write first? And the answer is no. You could write 3x minus 2 and then x plus 5, or you could write x plus 5 first and then 3x minus 2. It doesn't matter which set of parentheses you write first. Alright, which one is next? 5. Okay, so they're okay, what do you look for first? GCF. Is there a GCF for this one? Yes, there is. What would my GCF be? 2. So I'm going to have to divide that away first. Take out the 2. If you do not remove the GCF at the beginning, all of the numbers you're going to get for the rest of the question will be incorrect, and you will probably not be able to fix it when you get to the end. So you always need to take the GCF out at the beginning. Now what we're going to do, my final answer is going to have a 2. Once you guys know what the GCF is, write it here and then write it down so you don't forget to put it in your final answer. I'm just going to go ahead and do this. This is what I personally like to do, is just write down 2 empty sets of parentheses to fill in when I get to the end, so I don't forget the GCF. That's what I personally like to do, so I don't forget. Now what we're going to do is we're just going to factor what's inside of the parentheses now. Okay? So now multiply the first and last numbers. First number is 1, last number is negative 18, multiply them together, negative 18. What's the middle number? Okay, so what multiplies to get negative 18 but adds to get positive 3? 6, positive 6, and negative 3. Yes. Okay? Now what? Rewrite it. I'm going to have x squared plus 6x minus 3x minus 18. Remember, we're factoring what's in parentheses here. Don't use the printed question process. Right? Now what? Split it. What is it? That's what I'm asking. I know what's it called. GCF. Greatest common factor is X. What's up behind? Okay. What about on the right hand side? What's that like? So that was nice that it worked out, right? We used the correct GCF because everything worked out for the parenthetical expressions to be the same. So then what would my final answer be? I had the answer set up real and it's right here. Yes? Huh? What other way around? Yeah, exactly. You get the same answer. It doesn't matter what order you put them in. That would just make it too complicated if order back. Alright, which one's next? Say, okay, so these ones are. What do I do with this one? Take out the y. Put it there. Right? Number 6, so it looks exactly like this. But I need to change a couple signs. So make a note, remind yourself to put y back at the end. But then what else do you notice about this one? Now, with the way it's written. Oh, my word. There's a coefficient. The negative at the front would be considered as what? I know, I just asked you to rewrite it so it looks like what's on the screen. When there's a negative at the front, how do you treat that? Okay, so if you take it out, what are you treating it as? A greatest common factor. So this one does have a greatest common factor. That negative at the front is considered a GCF. So I'm going to have to take it out. So take out the y. The y is not a GCF, all right? This is different. Taking out the y and not rewriting it, that's just part of the solving process to make it easier for ourselves. So you take out the y, that's not a GCF. But the minus is a GCF, so I'm going to write that down here as part of my final answer. The minus is our GCF written at the front. Now I'm going to do the exact same process as I normally would for what's inside of the parentheses here. So I multiply the first and the last numbers together, get 8. The middle number is 6. So it multiplies to get 8, adds to get 6. 2 and 4. So I'm going to rewrite the middle term. Split down the middle. Then what? Okay. And then 2. GCF on the right. 4. That worked out nice. And then how would I write my final answer? X plus 4y. Remember, you put the y back, you attach the y to the numbers in each of the factors. And then x plus 2y. That's where you put the y back at the end. When you're writing your final answer, the y is not a GCF in this scenario. We're just getting rid of it so it doesn't jumble up our work. But then we put it back, attach them to the numbers at the end of each factor. And remember, your GCF that was there is at the very front of your answer. All right, does that make sense? Okay. there are a selection of others. There are 1, 2, 3, 4, 5, 6 that we have not done yet. I want you guys to pick 3. Pick 3 that you really, really like, and I want you to do those on your own. So of the 6 that remain, pick your favorite 3 and do those. And then I'll put the answers up so you can confirm that you got them. So pick your favorite 3. Please make sure that one of your 3 is either of these 2 that are highlighted. So you need to practice one of those on your own too. So pick 2 of the ones that aren't highlighted and 1 of the highlighted ones. So 3 total. Okay, so hopefully if you guys didn't get to do all the questions, maybe jot down the answers. If you want to go back in your notes and fill out the rest of them that you didn't do for practice, feel free to do that. What we're going to do now is a little activity that I have for you guys for practice that will be simple. So I passed out one of these little pieces of paper for everyone. Has anybody in here done a trail before? No?